Okay, so we're in the process of calculating the nth moments for a general normal distribution. So we have x, a random variable which is distributed normally with mean mu and variance sigma squared. And we want to work out the expected value of the nth moment of this random variable. And we know that we can write it in terms of the this function of a random variable which is standard normally distributed, i.e. with a mean 0 and variance 1. Okay, so we could expand this now using the binomial theorem, using the binomial expansion, and say that this is the sum from r is equal to 0 to n of n choose r sigma z to the power of r times mu to the power of n minus r. Now, again, we can rewrite that as the expected value of the sum r is equal to 0 to n of n choose r sigma to the r z to the r mu n minus r. And by linearity, we can firstly interchange the order of the summation and the taking the expected value. So this is equal to the sum r is equal to 0 to n of the expected value of what's inside, n choose r, sigma to the r, z to the r, mu to the n minus r. And then, secondly, by linearity, we can pull out all of these constants. N choose r is just a constant with respect to the expected value. Sigma to the r is just a constant. Mu to the n minus r is just a constant. So we can rewrite this as the sum r is equal to 0 to n of n choose r, sigma to the r, mu to the n minus r, the expected value of z to the r. So we can stick in now the expected value of z to the r, which we have up here as a formula. So we therefore get that it's the sum from r is equal to 0 to n of n choose r, sigma to the r, mu to the n minus r times r factorial divided by r over 2 factorial, 2 to the r over 2 factorial, over 2 rather. Okay, and that's only providing you've got, that's for the even ones. So what we need to do, we need to alter this summation so that you're only summing this up for even numbers. So sum over all even numbers between 0 and n. Oh, sorry, you can't see this. Between 0 and n. So for all the odd moments here, so for all the odd powers, z to the odd power, you're going to get 0 in there. But note that the expected values, the odd moments of a general normal distribution don't necessarily need to be 0.